Hello viewers, you are welcome to this video lecture. I am here to present the 13th video lecture from chapter 3. Chapter 3 deals about geometric design of the highway. In the previous videos will be deals about the introduction, about the geometric design, and also different type of design controls and criteria, the functional classification, terrain, nature's design, vehicles, density and characteristics, traffic volume and traffic composition, and also very important part is the design speeds will be deals. And also we'll have deals about the cross-sectional elements, different type of cross-section elements, traffic lanes, carriageway, shoulder, it may be right of way, drainage structures, median, also barrels at the median as well as the roadside. So different type of cross-sectional elements will be this. And also we'll have deals about the element of geometric design. We mostly will have deals about the side distance and the horizontal alignment, and also today's will be deals about the last topic is that will be the vertical alignment. In vertical alignment, there is specifies the elevation of points along the roadways. Mostly this vertical alignment will be there is a difference in elevation or grade. So these two elevations will be not sharp for the vehicles. It is more provide a curve. These curves will be a vertical curve. The elevation of these roadway points are usually determined by the need or the purpose to provide proper drainages as well as acceptable level of driver safety as well as comfort. As you see in the figures, it is provide there is a difference in elevation, so provide a vertical curves. A vertical alignment is establish a smooth transitions of the roads elevation between two grades. This transition is achieved using vertical curves, and mostly these vertical curves have two major aspects. The first will be the vertical curvature or the curve parts, and also will be the governed by the side distance criteria, the gradients, and related to the vehicle performance and level of service. So the grade will be higher or steeper. The performance of vehicles, it is, for example, for tractors, is difficult to clamp the grades, and also there is the speeds will be decreased. The level of service of all of the roads also will be decreased. The vertical alignment for transport facility consists of tangent grades. It is mostly will be called the straight line and the vertical curves. This vertical alignment is documented by the profile. So mostly we have the difference between the horizontal curve and vertical curves. In horizontal curves, there is there is a difference in direction. Two a straight line or tangents will be different in direction, so we provide simple curves or horizontal curves. But in vertical curves, there is a connection between two grades. There are two types of curves in vertical curves. The first is convex and concave. So for convex is summit curves, and also valley curves for concave curves. So the gradient is the rate of rising or fairness along the length of the roads with respect to the horizontal. So this gradient is very important to decide by designing the vertical curves. So this gradient will increase is related to the construction cost. For example, the grade will be very steeper, the construction cost also cost will be increased by that grades will be additional selecting material, so the construction cost is increasing, and also the operating cost will be increasing. So we have vehicles will be moving on the steep vertical curves. It is a lot of fuels will be lost, and also practical problems on sites related to safety, accidents, and steeper grades are avoided as far as possible. It is difficult to climb them, and increasing construction costs, safety, and operation cost will be increased. So the effect of the grades also will be the effect of a long steep gradients or vehicle speed is considerable. This is particularly important on the roads where the proportion of heavy vehicle is significant. So this side distance is restricted at uphill gradients. The speed of the vehicles also will be controlled by heavy vehicles. The speeds will be decreased and the operational cost will be increased, and also lastly the capacity of the roads will be decreased. So the gradient is also related to the accident. Representation of the grades is there is a positive grade will be denoted by n positive, and negative gradient will be represented by negative n's. There is a summit or convex will be curves are mostly it is upward gradients. This is formed by two gradient meets. The first is positive gradient meet with another positive, so as shown in the figure, the middle one. And when positive grade meets at gradient also will be forms upward. When an ascending gradient meets ascending gradient also will be seen at the third parts will be it is also will be give a so show in the figures, and also will be there is also positive and negative will meet also create summit curves. So this vertical curves is mostly fundamentals will be related to with a parabolic equation. In connecting to a roadway gradients with an appropriate vertical curves, mathematical relationships will be defined the roadway elevation at all points. So this parabolic function is represents apply for to vertical curves. Y is equal to a x squared plus bx plus c. So y is the roadway elevation, x will be it is station. Always will be measured from the beginning of vertical curve. C is the elevation at the beginning vertical curves, and also A and B are notice the first derivative of the upper parabolic equations, and also will be used as for vertical curves also will be used y is equal to r x squares over 2 plus g1. G1 is the first gradient, x plus elevation of beginning of vertical curve. So r is the rate of changing of the grades. So mostly we have gating from g1 g2 minus g1 over length, and also will be got x will be the distance from beginning vertical curves over 2. G1 is the starting grade, x will be the distance, and the elevation of beginning vertical curve will be get y. Y means elevation at a point, any elevation is at the curve. For example, this is the crest. So Some mid curves, it is formed by a positive and a negative. This one is beginning vertical curve. This is a point of intersection, and also this point is ending vertical curve. So the length is from beginning vertical curve is the length of the curve. This is, for example, it is a crest curve. It is formed by a positive 6% and a negative 3%. This the second type of vertical curve is a sag curve. So mostly a sag curve is formed by G1. It is a negative percent, 3%, and it is a positive. So for a crest curves. For examples, we will have two great lines intersect at stations. 2 plus 200. It is a point of intersection, vertical intersection, and the elevation is 239.5 meters. The starting grade is negative 6% and ending is 2%. So it is 6% is down and 2% is up, since the curve is a sag curve. So the length is from beginning vertical curve, ending vertical curve is 400 meter. So compute the elevation at station 2 plus 200. So at this R is equal to the grade difference over the length, G2 minus G1. G2 is 2% minus, and minus 6% will be 8% over 400 will be R will be 2%. And also beginning vertical curves also will be get from stations at the point of vertical intersection minus L over 2 length. So 2 plus 200 minus 400 over 2. So beginning vertical curve station is 2 plus 0, 0. And the elevation of beginning vertical curve is from elevation of vertical intersections plus the grade will be minus 6 times the distance. So slope times the distance will be get 251.5. It is 251.5. It is, so this is a sag curve. So the beginning vertical curve is greater than the vertical intersection elevation. So the elevation at y is equal to 0.02 times 2 square over 2 plus minus 6, 2 plus 251.5. It is at station 200, 2 plus 200 is 243.5. And also there are two type of vertical curves, crest and sag curves. So the minimum length of crest and sags have been designed to provide sufficient sloping side distance. So the K value, minimum allowable K value will be gated by the L over A, length of the vertical curve, and A will be the algebraic difference of the grades, G2 minus G1. And also will be the design speed is 100 km per hour. The sag curve is from standard K is equal to 51. So the algebraic difference in grade is 2 minus 6 is 6%. The minimum length will be K value is L over A. So L is equal to A times K. So the A value is the difference of the grades, 8% times the K value is 51. So the length from the beginning vertical curve, ending vertical curve is 408 meters. So we have C like this, negative, it is positive, or negative, negative, positive, positive, also will be form a sag curve. So, and also will be a critical length for grade for design also will be very important. The maximum gradient in itself is not complete design controls. It is additionally will be for the purpose of vehicles operations at the critical length of the curve refers to the maximum length of design upgrades, and also will be it is very important for the truck roads or heavy vehicles. So the factors to be considered for the determination of critical length of the curves are: the first is the size and power of representative tracks or track combinations to the use as a design vehicles, and also the speeds at entrance to the critical length of the curves, and lastly will be factor is the minimum speed at the grades. So we try to design a vertical curve. It is a crest. So a crest, a vertical curve join positive 3% and negative 4%, and the design speeds will be 75 miles per hour. If the tangent intersects at a station, the point of intersection is 345 plus 16, and the elevation is 250 feet. So the required one is station elevation at the beginning vertical curve, and also ending vertical curves will be required for calculation. And also will be calculate the elevations of intermediate points on the curves as a whole station. So we have can calculate for the design speed is 75 miles per hour, k value is 312, so the minimum length will be get from k times a means it is algebraic difference g2 minus g1 minus 4, and also will be 3, so 3 minus 4 will be it is positive 7 per, so 312 times 7 is 2184 feet. It is the distance between ending vertical curve and beginning vertical curve. So stations are beginning vertical curve is calculated as the station at point of intersection minus L over 2. So 345 plus 16 minus 21 plus 84 over 2. So this the station at the beginning vertical curve is 334 plus 68. That also will be station at ending vertical curve is also will be calculated station beginning vertical curve plus the length. So the length will be 21 plus 84, so we have plus in 334 plus 68, so totally will be get 356 plus 52. And also will be calculated as the elevation of beginning vertical curve. It is from it is a crest, so minus from the point of intersection is elevation. So point of intersection elevation will be 215 minus the slope is 3 times the length is L over 2 will be 21 plus 84 over 2. So the elevation of beginning vertical curve is 217.24. So comparing to the point of intersection is elevation will be laser. So point of vertical intersection is 215, so elevation at the beginning vertical curve will be 217.24. So stations will be 334 plus 68, and also beginning vertical curve will be 345 plus 16, and ending vertical curve will be 356 plus 52. So we have calculated the elevation at the curves at each whole station. So the beginning vertical curve will be 334 plus 68. So the next whole station is 335 plus 00, and this third one is 336 plus 00. So the last is beginning vertical, ending vertical curve. So the distance is x will be always from the beginning vertical curve. There is it is 0. So as a whole equation, there is 100 minus 68 is 32, and next it is the difference is 100. So 132 to 132 will add like this. So the tangential elevation at the beginning vertical curve is 270.24. So we have calculated by using this formula. And the offset, we have calculated the elevation y x ax squared over 200 times l. So this one is at offset. The offset means these elevations will be from this at the tangent. So it is offset. So the tangent elevations will be this one, the offset will be minus this one. So and lastly will be gauges the curve elevation. So the curve elevations will be at the point of intersections, as these points are the curve elevation. So first will be determine the tangential elevation, and also will be calculate the offset. So the tangent elevation minus the offset will be get the curve. So this one is minus, for example, 218.20 minus 0.02. It is 218.18. 281.20 minus 0.28. It is 220.92, like that. So we have calculated like this. It is positive, and also for design for the sub vertical curves also will be calculated. It is negative, but it is 3%, and it is positive 3%. If the point of vertical intersections will be stations as this point will be 435.15, and the elevation also we will have 235. So determine the station elevation at the beginning vertical curve as well as ending vertical curve. So the design speed is 17 mile per hour, and also we compute the elevation on the curves 100 feet interval. So it is a full interval. So in this case, the minimum k value is 181. The minimum length is the minimum length will be k value times the algebraic difference. So we have get 2086, and station of beginning vertical curve also will be get from station at the point of vertical intersections minus this one is 435 plus 15 minus the distance L over 2. So minus the distance L over 2, we have get 416 plus 00. The ending vertical curve also will be plus the distance 440 plus 82. The elevation also will be get from the point of intersection times the slope times the L over 2. So 251.29, and the elevation of ending vertical curves also will be the same. It is the same. So beginning vertical curves also will be the distance from the beginning vertical curve is 0, and the next whole station or 100 feet intervals is 96, 193 is after. The tangent elevation will be determined as the beginning 251.29, and the second elevation will be, it is a sag curve, the elevation will be decrease. For C like this, it is the elevation is down, so we have decreasing the elevation. So first will be determined the elevation at the tangent, so determine the, and second is determine the offset. So the elevation of the tangent, the elevation of tangent plus offset plus the offset, we have get the elevation of the curve. So this one, so this one plus this one, this one plus 248.15 plus 0.24, it is